Hello everyone, this is Shahriyar Chowdhury and today I will be talking about my research project that is database technology on decision support system. So when it comes to big businesses that are dealing with technology that and has like big IT infrastructure, decision support system is the core of those businesses. The reason is that these days businesses are collecting, maintaining, and analyzing large amounts of data, which involves huge technical challenges, expenses, and the organization obviously uses those data to make numerous day-to-day business decisions. So first of all, I would like to introduce you with the architecture of decision support system, and that is based on the three principal components. Those are a data warehouse server, data analysis and data mining tools. The third one is data warehouse backend tools. That is the ETL process. Before going more depth into the topic, let me take a little bit about let me talk about a little bit about data warehouse. So data warehouse is a management system that was designed to do business analytics and are solely intended to perform queries and analyze analysis of large amounts of historical data. Not only that, most of the data warehouses use relational database technology still now, and because it offers a reliable and effective way for storing and maintaining large amounts of data. So one of the most common issue that we still see in data warehouse is the construction of the database design that requires extensive business modeling, both logical and physical. So as you can see here that the data warehouse contain data from several different operational database, mostly in terabyte sizes. So these are maintained separately from the organizational operational data because of the analytical application performance that has different requirements are that are mostly different from the operational database in a way. So as the warehouse construction is a complex process, as we know, and that takes like years to build up. So the data marts, as you can see here, is can be an optional that contains more information about the specific department subsets. So several data marts can coexist within the data warehouse and can provide partial view of data warehouse contents. So now I would like to talk about a little bit about the ETL process. So data warehouse backend tools are mostly listed as ETL as we see previously right here, which is the backend tools. The ETL process is extract, transform, and load, as we see here. So what is this one? So the main thing about the extraction and transformation of the steps to bring the data from a desperate from a desperate sources, as we see here, right? So the sources are so the data is being transferred from the sources to the data warehouse, and we use ETL process for that. So the extraction and transformation of the steps obviously to bring those data in sources into the database, but this is where we can modify and incorporate data incorporate yeah, into the data warehouse. And the main goal here is to find the discrepancies in schema and attribute value convection. So the another one is about the loading. So after the extraction and transformation, data might still require additional processing before loading into the data warehouse. So those can be handled using the batch load utilities handles functions by checking the integrity constraint, sorting, summarizing, aggregating, and performing other computationals to build derived tables that are stored in the warehouse. Moving to the next slide, that is the data preparation and data mining. So data preparation, in the data preparation phase, we see that the analyst will prepare a data set that contains enough information to build accurate models in subsequent phases. So the data preparation can involve complex queries with large data results. Data mining platforms can use OLAP or relational servers to meet data to meet data preparation requirements. So it typically involves integrity building models on a prepared data set and then deploying one or more models, as the building models on a large data set is expensive, and as we know that, and analysts often work initially with a sample set. So now I will talk about a little bit about the So as we see the OLAP services, servers and middleware architectures, and it consists of three different ones, that is ROLAP, MOLAP, and HOLAP. So first, let me talk about the OLAP. So OLAP was introduced to businesses as the online analytical processing tools that has the ability to pre-calculate and that has the ability to do pre-calculate and pre-aggregate data, and the data mining platforms and the and the data mining platforms can use OLAP to meet data preparation requirements. So OLAP analysis can involve more complex statistical calculations than simple aggregation, such as sum, count, and average. There are limitations of OLAP as it requires restructuring of data into snowflake schema, and the limited number of dimensions fails in a single OLAP use OLAP cube. The next one is rollup. Rollup is a form of OLAP in a way that performs multidimensional analysis of data stored in a relational database rather than the multidimensional database, and considered as standard OLAP. So the rollup middleware servers sit between the relational backend and the client frontend tools, and rollup supports multidimensional OLAP queries and typically basically optimized for specific backend relational servers. Moving to the next one, which is MOLAP. So the MOLAP means multidimensional online analytical processing tool. It uses multidimensional cube that has the access to store data through various combination, whether the data is pre-computed or pre-summarized. So MOLAP MOLAP is a native server architecture that does not exploit the functionality of a relational backend, but directly support a multidimensional data view through a multidimensional storage. The last one is HOLAP. This is basically a hybrid online analytical processing that is a combine of relational OLAP and multidimensional OLAP, and it was developed to combine the greater data capacity of ROLAP with the super processing capability of OLAP. The last, not the least, is the data cleaning. So for the data cleaning is basically data entry errors and differences in schema conventions can cause tables to have several corresponding tuples for a single customer data entry. So that is where it can make inaccurate query resulting in inappropriate mining models. So data cleaning is really important in any organization. Thank you.